Infinity over infinity.
But there are others, and I just heard one. What was it?
Infinity over infinity.
And it might be infinity over negative infinity. It might be negative infinity over positive infinity, but I mean, these are just some examples of what? In an indeterminate form. Are they listed in your textbook if you wanted to see them all? Yeah, you'll see a bunch of them. It's on page 302, you have to look now, but here's two key important what? Formats for indeterminate form. Alright. Now, this is just another technique to help us define limits. We already know in a bunch, right? Actually, three ways. We've done it graphically, we've done it numerically, and we've done it algebraically, especially when we got an indeterminate form. We've been multiplying conjugates, simplifying fractions. Do you remember that on test one?
Mm-hmm.
And you were all very good. This is where you get mad at me and you go, why didn't you show us this way? Because L'Hopital, this mathematician, when they came up with this, it's just a really neat technique to find limits of functions, especially when you get this indeterminate form to pop up. So let's start with something really basic. Something like that. Now I think you are going to look at this and know an easier way to do that. But I want, do you agree? Go ahead and substitute that 2 in there. You get 0 over 0?
Mm-hmm.
Okay. But what did we do back on test 1? Because it works and you can still do it.
You could factor it.
I heard it, you could factor it. Then you could cancel, right? So when you recall this, look, you're over 0, we said that means you got to keep going. That means there could be a limit there, right? So what we did was, we algebraically manipulated it. We would sit there and maybe do something like this, cancel these, then we took the 2 and we what?
Plugged it in.
Remember this? So now you get 2 plus 2, what's the answer?
4.
Is this okay with that? But that's not this lesson. I think you're going to like this section a lot better. Because back then, you and I had to be the master algebraic manipulator. We had to know about multiplying conjugates and doing common denominators, factoring, expanding things, right? L'Hopital's got it easy. He says this, right? If you get indeterminate form, right? Remember when he loved when you put an equal sign and put an H, just to say I'm now going to apply L'Hopital's rule. Don't do quotient rule. This is easier than quotient rule. Just differentiate the top and differentiate the bottom and plug it in again. No, you gotta be kidding. Yeah, that's simple. So I want you to differentiate x squared minus 4. What do you all get?
2x.
Yeah, I'm not talking about quotient rule or anything like that. No, just the top. It's like, okay, that'd be 2x. And how about the derivative of x minus 2?
1.
And then he goes, now substitute. What do you get?
4.
You may find this a lot easier. I thought someone in here was going to yell at me. This is where you go. Why didn't you show me this in test 1? I could have got all these problems. Well, we didn't learn derivatives really yet. We just got barely into it with the definition. You know? So, that's it. But let's see a whole slew of problems. If you got your textbook, and when he loaded this section. He's like, Kadoon, try all these limit problems. So let's do a bunch. Plus they're fun because what are we going to do for the next half hour before you leave today?
But professor,
We're just going to do a bunch of derivatives, right?
I got a question.
Oh, go ahead.
Now this L'Hopital's rule, right? The
Right.
thing that was like bothered me like during the first test was the sine of x over x when it goes to 0 is 1. That is the one he was doing.
Oh, can we do it now?
Yeah, in L'Hopital's rule is 1, but if I was trying to do it, I mean like it was always coming to 0.
No, it's hard the other way. It's
Yeah.
very hard the other way. Okay, let's show everyone that.
Okay.
This, yeah, you go, what's another way to do this? And boy, it is tough. It's even tough graphing. I mean, we got a nice graphing calculator, but to approach it just like numerically, I mean, and algebraically, what are we going to use? What are you going to put for sine of x over x?
Yeah.
So Art just came up with a good one. This came up earlier, and by far, this is going to be the easiest technique to hit it. No, seriously, you're gonna say, oh, put that on a test. Right there, you're gonna put that one on a test. Because that one, what's the sign of 0?
0.
Zero.
And you get a 0 in the bottom? Don't we have an indeterminate form?
Mhm.
These are indeterminate forms. So we'll just go, alright, I'm getting a 0 over 0, that's going indeterminate form. Now what does L'Hopital like you to do?
H.
We put an equal sign and let's just put a what?
H.
When we write that, you go, what are you doing? We're saying we're applying his rule. We're going to apply his rule and then substitute the number in there. Cool? What's their sign?
Cosine.
Alright. What's their of x?
1.
You're like, are you kidding me? We're going to be done. Be careful. Cosine of 0 is not 0.
1.
The answer is 1. Now, and if you want to look at this, Art and I were talking about, okay, that's easy, but other ways, very challenging. If you got a graphing utility, you can make the graph and you can see that the limit's 1. But other than that, you know, if you say, what's an algebraic approach to do this? You and I know a bunch of trig identities. We'd still have to sit there and try to manipulate that thing to make it work. Cool. We know we got the squeeze theorem, that's sometimes handy. But boy, this really just makes limits a lot easier, huh? Hey, we're gonna do a bunch. You know in a final one I like to do like 30 multiple choice problems? Well, let's say 4 of them were limit questions. Doesn't that fair game? Doesn't that mean you can use any technique you've learned in a class? You could use L'Hopital's rule, right? I mean, you could do, the factoring. So sometimes there's 2 ways to do it. If I did that x squared minus 4 over x minus 2. But please be careful. I always say this. Please be careful. Don't be using L'Hopital and stuff like this, right? I'm going to do L'Hopital. Sometimes people just automatically assume, start doing L'Hopitals. And when you plug in 1 here on the top, what do you get?
1.
A 1. You plug in a 1 in the bottom,
0.
you get natural log of 1, which is 0. And your first step, you're getting 1 over what?
0.
Zero.
This is not indeterminate form. That means non-existent limit. This is a 2-sided limit question. Do you see that number right there? That is not indeterminate form. That means non-existent limit. And you say it's non-existent. Does not exist. Do you follow me? See, what's the danger of this? Trying to find all of a sudden you start, oh, I'll take the derivative of x, I'll take the derivative of that, and you're going to get the wrong answer. Does that make sense? We're only going to do this when we have what?
Indeterminate.
These indeterminate forms.
So L'Hopital's form is only for indeterminate, right?
That's right.
L'Hopital.
Now, when I can make one like this, though, you want to see it? Now, what would be the answer to this? Limit as x approaches 1 of x over round of x. Does not what?
Exist.
Does not exist. DNE, non-existent. True? But I could make up one. It's easy to make one up. Try this one. Okay, there you go. I made this one up.
That's yeah, 0 over 0.
Aha, everyone, substitute the 1 in there. What do you get on top when you plug in a 1? 0. What's the natural log of 1?
0.
And you now say, alright, let's do L'Hopital's rule, right? Let's do Lopi. Alright, Lopi, put what, an H?
Mm-hmm.
Just because it's cool. What's the H for it, that H? It just means we're applying what?
Derivative.
L'Hopital.
L'Hopital, yeah.
Plus, you might do this like in a differential equations class. That notation, your professor or instructor would understand it. Now, what's derivative of x minus 1?
1.
Who knows the derivative of
1 over x.
Now, when we divide fractions, that looks kind of goofy to me. That's called a complex fraction. When you divide fractions, you multiply the... Yeah, they're reciprocals. Let me rewrite that.
So it becomes
This sometimes throws students off. They go, oh, I don't know what to do now. Well, you can plug it in now and get the answer, but sometimes it looks nicer if you just say what? This is also equal to, everyone, I'm just going to multiply the reciprocal. That's what?
X.
X over 1, isn't it? I just took that and went like that. But hey, I don't think you have to, because right now you can plug in a what? Jess, you can finish it up right now and get the answer. What's the limit of this function?
One.
One. Because we took this. So far, so good? Now let me go back to something we've done earlier in this class. With the Horaces. Remember the Horaces? Remember the horizontal asymptotes? Remember those? Limits to infinity? Alright. We need to do a problem like this. So this was from test number 1. Okay?
Okay.
And you probably got it right, but I want you to apply L'Hopital's rule here if you can. So test 1, you had to find this. The limit as x approached infinity of 3x squared minus 4 all over 2x squared plus 1. Now that was on test 1. A lot of you figured this out by knowing it's a rational function, it has a horizontal asymptote. And you found the horizontal asymptote, you knew what the limit was. But now you know L'Hopital's rule. And what's 3 times an infinite value squared minus 4? Isn't that infinitely large? Think about that. 3 times an infinitely large number squared, that's infinitely large, minus 4, it's still infinitely large, like infinity. And over 2 times an infinitely large value.
Infinity.
I have to say that because infinity is not really a number, is it?
No.
It's just some infinity. You're like, 2 times infinity squared. Infinite, it's just humongous, right? Infinitely large, it's huge, plus 1. So I'm getting infinity over infinity. Indeterminate form. So what can I do?
L.
Let's do it, 3x squared.
6x.
6x.
4x.
Now when I'm upset, but you can help me out with this. Now I go back to plug infinity, I'm getting 6 times infinity over 4 times infinity. I'm getting infinity over infinity again.
So divide by x.
What should I do?
Divide
Can I
by
apply Lopi again?
Yeah.
Yeah! Oh, and you can keep going with Lopi if you keep getting what? Isn't that cool? You might have problems where it happens 3 times in a row. Just keep crunching it down, right? Alright. Oh, I'm getting what? Infinity over infinity. 6 times infinity over 4 times infinity, infinity over infinity. Or an infinitely large number over an infinitely large number. So, what's that? That should be the answer.
230.
That was the answer on the test, but a lot of you
Yeah.
reduced it to what?
Yeah.
Do you remember that?
Mhm.
I don't know, you might find it easier to just go, oh, well, the horizontal asymptote is 3/2, I'll just put that. When you're on your final, right? Amber, do you remember if you got that one?
Would you do after 6x over 4x? Would you do after?
Oh, I actually applied L'Hopital's rule a second time. Because I had infinity over infinity. I had 6 times an it's infinity, over 4 times an infinity. I had this again. And I can just do another round of Lopi.
Oh, then you got the.
Yeah. Ben,
Shouldn't you put the limit symbol out in front of 6x over 4x?
you can definitely do that. I think it's a great idea. And if you always want to write that what? That limit expression each time. Because eventually we're going to do what? Substitute this value here. You got it. Great call. Is that okay with this? Alright. Alright, Owen, I'm going to try to stay to even numbers. I'll probably make some up along the way for the next 25 minutes. Does that sound cool? And then I'm going to end with my favorite, number 61. Because you go, whoa. And when number 61 is this. Do you remember this junk?
Mm-hmm.
I know, look. And remember a like x to the 1 over x, or x to an x. Remember these?
Mm-hmm.
They're kind of weird. Or x. We've only seen like 1 or 2 of these so far. Okay? So I'll end on that guy. Don't let it freak you out. That one with x to an x. You go, what the x to an x? How do you differentiate that? You might remember something we can do. Okay? Alright. Let's try some of these. I'll put this away. Limit. I'll try to keep you on your toes, so every once in a while I'll probably give you something that is an indeterminate form and just plug a number. Sound good? Like that. What do you do? Should I do L'Hopital's rule?
No,
What do we do?
it's pi over 4.
No, don't you just plug it in?
Yeah.
Alright, good. So always keep that in mind. Don't think everything's L'Hopital's rule, right? That's the bad part when you get a section like this. It seems like every problem, you know, right there I just substitute 3. Pi over 3 plus 1 is pi over what?
4.
That's the answer. Alright, throw that one away. Try this one. Should I go to 0? Nah, I think I'll go to infinity. Can anyone read it? Can anyone read it?
Mm-hmm.
You do it, just do it quick. Everyone, what do y'all think? Can I do Lopi?
Yes. Mm-hmm.
I agree. X plus x squared. Infinity plus infinity squared. Over 5 minus 3 times infinity squared. It sounds like I get an infinitely large number over a negative infinitely large number.
Mm-hmm.
So that means everyone look. That's also an indeterminate form. Yeah. Like something's approaching infinity, infinitely large, or something that's, you know, infinitely large but negative. So what can I do? Some of you might already beat me and just did the horizontal asymptote on this. I'm going to keep going. What's the derivative? 1 plus
2x
2x.
minus 6x.
Now,
Again